Hello, here we are, 1.9 distance and midpoint formulas, and we're also going to be talking about circles in this section. So let's just begin with the objectives. Our objectives are going to be finding the distance between 2 points on the Cartesian plane. So it just basically gets the ordered pairs, and there's a little formula that we're going to need to use, which basically is using the Pythagorean theorem. But we'll talk about that when we get there, and we've got to find the midpoint of the line segment. So it's basically the point right dead center of the line segment that connects those 2 points. We're also going to write the standard form of a circle's equation. We're going to give the center and the radius of the circle, whose equation is in standard form. We're going to convert the general form of a circle's equation to standard form. That's going to require completing the square. Okay, so those are our 5 objectives for this section. So let's just begin. So the distance formula D between points x1, y1 and x2, y2. So these are 2 points on the Cartesian plane, or the rectangular coordinate system. And the distance between them is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, if you note, the Pythagorean theorem is c squared equals a squared plus b squared. And so if you solve for c, it would be taking the square root of the other side. So it would be c equals the square root of a squared plus b squared, which makes it look a little bit like this one. But a is just the distance of one of the legs, and b is the distance of the other leg. And the c is the distance of the hypotenuse. Well, the hypotenuse is the distance in this case. But the a and the b, okay, are the legs. So x2 minus x1 represents the distance of a, and y2 minus y1 represents the distance of b. Okay, so this is really just the Pythagorean theorem in disguise. Okay, to compute the distance between 2 points, find the square of the difference between the x-coordinates plus the square of the difference between the y-coordinates. The principal square root of the sum is the distance. So they're just trying to give you the formula in a wording format. So these last 4 lines is just a wording format of the distance formula. All right? So example. So we're going to use the distance formula. So we're going to find the distance between -1, -3, and 2, +3. Express the answer in simplified radical form and then round to the two decimal places. So solution. So distance equals the square root of x2 minus x1 plus y2 minus y1, and you square both of those differences. Now it really doesn't matter which one you choose for x2 and which one you choose for x1, as long as they're x coordinates. And the y2 minus the y1, same thing. Okay, so if you do x2 minus x1, well, they're taking the x2 to be 2 and the x1 to be -1. So you're subtracting 2, take away -1, squaring that, plus the difference of the y-coordinate. So it'd be the second y-coordinate is 3, first y-coordinate is -3. So it's 3 take away -3. So doing the math on that, that's going to be 2 take away -1. That's going to be 2 plus 1 is 3, and then 3 squared, and then 3 take away -3 is 6 squared, and then it'll be 3 squared is 9, 6 squared is 36, so the square root of 45. And we're also in chapter preliminary section is when we try to simplify the square root of 45, we look out for perfect squares. So the square root of 45 is the square root of 9 times the square root of 5, which is 3 radical 5. And if you're going to use your calculator on that, it's approximately 6.71. If you note that the square root of 49 is about 7, so it makes sense that the square root of 45 is a little less than 7. So the difference between those 2 ordered pairs on the Cartesian plane is 6.71 approximately units. So, all righty. Now let's talk about the midpoint formula. The midpoint formula is the point is kind of right dead center of the line segment that connects the 2 points themselves. It's kind of like the average. So consider a line segment whose points are x1, y1, and x2, y2. The coordinates of the segment's midpoint is the average of the x coordinates, so it's add them up, divide by 2. And then the y coordinate of your midpoint is averaging up the 2 y coordinates. the one that's on the left versus the one on the right, add them up and divide by 2. Okay? So in wording, to find the midpoint, take the average of the two x coordinates and the average of the two y coordinates. All righty. So example, we're going to use the midpoint formula. So finding the midpoint of a line segment with whose endpoints are 1, 2, and 7, negative 3. So solution. So we average the x coordinates, so add them up and divide by 2. So it'll be 1 plus 7 over 2 and 2 plus negative 3 divided by 2. 1 plus 7 is 8 over 2, which is 4. And 2 plus negative 3 is negative 1 divided by 2 is negative 1/2. So 4 comma negative 1/2 is the point right in the middle of that line segment. It's called the midpoint. Okay? The biggest problem students have with this is that they subtract the coordinates, not add the coordinates for some reason. If you just think about the average, you're probably more likely to remember, because if you have 2 test scores, how do you find your average? You don't subtract them and divide by 2, do you? If you have 2 test scores, you want to know what your average is. You add them up and divide by 2. Okay? So think of it as the average. All righty? But yeah, a lot of times people get this formula mixed up by just subtracting them. And I think they're getting them mixed up with the slope. If you remember the slope, you subtract the y coordinates, subtract the x coordinates, and it's also with the distance formula. The distance formula is also, you're subtracting them. So they're mixing them up with one of those 2 formulas, okay? But in this case, you add them up, okay, and divide by 2. All right? All right, definition of a circle. A circle is a set of points, the set of all points in a plane that are equal distance from a fixed point called the center. The fixed distance from the circle's center is to any point on the circle is called the radius. So basically the distance from the center to a point on the circle is called the radius. The center is the fixed point in the middle. Now notice that they use the word in a plane. And that kind of sometimes goes, unobserved by students. They don't see, I mean, they see it's a set of points around a fixed point, but they kind of fluff off or not pay much attention to the words in a plane, and that's important. Because if those 3 words are not in this definition, you'd be defining a sphere. Because a circle is a set of points in a plane that does this, but a sphere is a set of points in 3 dimensions. It doesn't have to be it's not in a plane. And that's a sphere. It's like a basketball. Okay? So if you have to define the word circle, you have to put the words in a plane in there. And it's the standard form of the equation of a circle is, with a center HK, is given by that formula, x minus 8 squared plus y minus k squared equals r squared. And you look at that formula and you're like, oh, it's another formula. Really, this is another formula that's kind of, it's a copy of a different formula, but just in a different format. If you remember, I told you the distance formula comes from the Pythagorean theorem. Well, this formula comes from the distance formula. So the equation of a circle is just kind of like the distance formula, because if you remember, d is equals to the square root of the difference of the x coordinates and the difference of the y coordinates. Well, the difference of the x coordinates is x minus h in this case, because h is the center, the x coordinate of the center. So, and then the k is the y coordinate of the center. So you're finding basically the radius is equals to the square root of those 2 things. So that's the distance between the center to a point on the circle, right? Well, all they're doing is now squaring both sides to get rid of that radical. So if you put the formula for a circle right beside the distance formula and kind of overlay them, and then look at them, and you'll see that there's some things that line up. Okay, I know the radical is on one of them, but if you got rid of the radical on the distance formula by squaring the other side, they would almost overlay perfectly. They're just using different letters here. Okay. All right, example, finding the standard form of a circle's equation. Okay, so write the standard form of an equation of a circle with center 0, -6, and radius 10. So this is pretty easy. You just use the equation of a circle. So the circle's radius is 10, but the center is 0, -6. So it's x minus 0 squared plus y take away -6 squared equals 10 squared. So you get x squared plus y plus 6, because two minuses make a positive. So it'll be y plus 6 squared equals 100. The standard form of the equation of a circle is x squared plus y plus 6 squared equals 100 in this case. Now understand what this is saying. This is basically the equation that defines that description. So if you want other points on that circle, then what you would have to do is put an x coordinate in there and solve for y, or conversely. So this just gives you an equation that will give you any point within that circle. All right. Now, this is another example using the standard form of a circle's equation to identify the center and the radius of a circle. Okay, so find the center and the radius of a circle whose equation is given. So if you have x plus 3 squared plus y minus 1 squared equals 4, and then you overlay the formula of that, the h represents -3, and the k is 1, because you remember it's x minus h. So negative h equals 3, which makes h equals -3. And then y minus k would be y minus 1 in this case, so k would just obviously be 1. So the center is a -3, 1. Now the radius squared is 4. So what does that make the radius? Square root of 4, which is 2. All right? So simple as that. Now this was an easy one. Okay? Sometimes we're going to see in a bit that they're not always in standard form. They're in what we call general form. And this is the general form of a circle. So the general form of an equation of a circle is x squared plus y squared plus dx plus ey plus f equals 0. I know that looks kind of daunting there, but all they're basically saying is you have an x squared along with another x term, and you have a y squared along with another y term, ey, and then plus a constant. And it's set equal to 0. And d, e, and f are just real numbers. So it looks kind of, looks kind of daunting there, but it's really, you just got to understand d, e, and f are just numbers. And you're going to be basically taking this equation, manipulating it, put it back in standard form by completing the square to identify the center and the radius, like we did on the previous example. Okay? So let's look at an example. We're going to convert the general form of a circle to standard form. So we have x squared plus y squared plus 4x, and I remember we had the dx, so dx is 4x in this case, minus 4y. Remember we had ey, now it's minus 4y, minus 1, and now the negative 1 is df, equals 0. So we're going to put that equation in standard form. So what we're going to do is we're going to rearrange the terms so that the x's are together and the y's are together. So we'll have x squared plus 4x, and then we'll have plus y squared minus 4y. So I'm just rearranging the terms, and then while I'm at it, I'm taking that minus 1 and moving it to the other side, because that's not part of the x's and the y's. So then you have x squared minus 4x plus 4. Why plus 4? Why did they put a plus 4 there? It's so they can actually complete the square. Because you remember you take half of 4 and then square it, and that makes 4. And then the y squared minus 4y, we'll take half of negative 4, that's negative 2, and you square that, and that's 4. Notice at the same time, they're adding those 4s that they added to the left on the right side. So that's why it's now 1 plus 4 plus 4. Because the first 4 that they added is the middle 4, and then the 4 on the right is the 4 that's on the second part of that expression on the left side of the equation. So then you have x squared plus 4x plus 4 turns into x plus 2 quantity squared, because it's x plus 2 times x plus 2. And the other one is y minus 2 times y minus 2, which is y minus 2 squared. And that equals 9 on the right. How come? Because it's 1 plus 4 plus 4. And that's 9. Now it's in standard form. So you have to complete the square basically 2 times to get the equation from general form to standard form. But before you can do that, you have to rearrange the terms. Okay, so when we got it in standard form, the center is going to be negative 2, 2. Remember, it's x minus h, so minus h is 2, so h is negative 2. And then the k, y minus k equals y minus 2, so k obviously is 2. So negative 2 is the center. So if you look at my graph here, negative 2, 2 is a point within the second quadrant. That's that blue point there. The radius of the circle is the square root of 9. Now remember, the right side is r squared. So r squared equals 9. And so r is square root of 9, which is 3. So what you do is you count 3 units over and just kind of draw the best circle you can. And I don't expect you guys, when we're doing these circles, I don't expect you to go out and buy a compass. You don't need a compass for this course. We're just going to kind of give it a rough idea. And I mean, as long as it looks somewhat like a circle with that radius, we're good. Okay, you'll get better at it as you're graphing them. I haven't seen too many people that can draw a perfect circle, including myself. Okay, I've seen some students do it with just freehanded. They're good artists. But they don't. Those kind of people don't come along very often. So, because I know I can't draw a perfect circle at all. So, but we want to be kind of close to be in the vicinity of what we need to have. So, but I don't expect you guys to go out and buy a compass. They don't cost that much, but no more than we're going to need it. It's not worth spending the money if you don't already have one. So, okay, so. Believe it or not, that is it. That is this section. It's a relatively short section, okay? Most of you guys, I understand, you probably have seen this in one form or another, okay? And I'm hoping between this and the other things that you're going to be doing, watching the other videos from the book and everything else, this won't be too tough of a section for you, okay? So... But anyway, as always, if you have any questions for me, you need to let me know, and we can take care of it. The biggest trouble that students will probably have with this section, if anything, is either memorizing the formula correctly, like the distance formula or the midpoint formula, or another thing that students will have trouble with usually on this one is being able to complete the square as we did on this example. Okay, so probably you'd want to watch more of the videos that's within our My Math Lab. That might be of help as well to help you complete the square. You might want to go back and learn how to complete the square from the previous section that we've done. So that might be helpful. So just kind of remind you of how to do that sort of thing. So, but like I said, it's not that hard if you can remember a few formulas and complete the square. Okay, so again, you should have been taking notes all along here. If you did and you forgot to do it, probably it'd be a good idea to go back and just take it one slide at a time, and at least write the examples down. Okay, maybe not the content so much, but write the examples down that I did here. So, okay, I will see you on the next video, and until then, you have a good day.